Page 739. So one of the things we noticed was that when you expand a binomial, that the coefficients were the same as Pascal's triangle. So if we write Pascal's triangle off to the side, and you remember you can always find the next term by adding the 2 above it. And we could keep going, but another thing that we noticed is when we expanded something, the number of terms in the expansion was always 1 more than the exponent. So the fact that we're expanding something with an exponent of 4, in the expansion, this tells us that there's going to be 5 terms. So when looking at Pascal's triangle, we have to find which row has 5 terms. It's going to be this one, and that's why I stopped at that row, because I knew I wouldn't have to go any further. So when we try to expand this, we're going to find out that 3b minus 1 to the power of 4 is going to equal, and you're going to have to try to space the coefficients out so you have enough room to write things in between. Those will be our coefficients. Another thing that we noticed when we expanded things is whatever our first term was, you start by having 4 of them, and then you go down by 1. Yeah. Each time until you get none left. And with our second term, you start with none of them, and you keep going up by 1 each time until you get to the end. If you look at the exponents in each term, you will always know that they add up to 4. So we start with 4 and none, 3 and 1, 2 and 2, 3 and 1 again, and 4 and 0. So your exponents always add up to whatever your original exponent was. And then you'll have a plus sign adding these terms in between each one. So you see why you need to spread it out, because you end up writing a lot of things. Then to simplify it, we need to follow our order of operations. We'll do our exponents first. What happens when I have 3b to the power of 4? Well, that power of 4 goes to the 3. 3 to the power of 4 is 81. b to the 4. Here we're going, and I'm going to do this in more than one step. I'm going to do my exponents first. 3 to the power of 3 will be 27 b cubed, and I'll still have a negative 1 there, plus 6. 3 squared will be 9b squared. And what's going to happen when you do negative 1 squared? Just going to become 1. And here we're going to get 4 times 3b. What's going to happen negative 1 cubed? Negative 1. And negative 1 to the 4 will just be positive 1. So I simplified all my exponents first. And now I can multiply things out completely. 4 times 27 times negative 1 will actually be negative 108. So we can write that as a subtraction. B cubed. 6 times 9 is 54. B squared. 12 times negative 1 will be negative 12b plus 1. So again, we were able to use Pascal's triangle to find out those green numbers, those coefficients in front. Then think of our patterns, how they went down by 1, each one for our first term, and up by 1 each time for our second term. Whenever you have a negative inside your expansion, that negative will go with that second term, And it's important that you put that in brackets. And your exponent is outside of those brackets, just for your notation, so you don't mix up what's positive and what's negative. So as far as practice go, we're going to take some time to try some of these right now. 3 and 4.